Welcome to the Semblex Solutions at Work mini video series. I am Brant Ruskowitz, the Product Development Manager at Semblex, which is a specialty fastener company in the Chicago area. In this video series, we will evaluate the latest fastening technologies available through Semblex and look at some of the potential applications for each technology. Flow drill fasteners are a type of hole-forming, self-threading fastener often used in aluminum and mixed material automotive body structure. The fasteners are installed with a four-step process. First, we have the finding step, where the driver engages the drive system on the fastener's head. This is typically done inside the machine's jaws and is not visible. Second, we have the penetration or passage step. During this step, the fastener uses frictional heat to soften the material and create a hole. The materials do not melt, they just soften and move. Once the hole is created, we enter the third step, which is where we're going to roll form threads into the hole that we created during the penetration step. We'll then move to the fourth step, where we're going to tighten to a target torque to secure the joint. Flow drill fasteners are most common in aluminum to aluminum applications, but they also work in aluminum to steel applications, magnesium applications, and composite to aluminum joints. Flow drill fastening is a single-sided technology that only requires access to one side of the joint. These fasteners are often used with adhesive to create joint strength. The adhesive does not have any significant effect on the installation process. However, specialized equipment is required to install a flow drill fastener. The equipment is available from three major companies: Weber, DeProg, and Atlas Copco. Semblex partners with all three of these companies and has their equipment available for testing in our lab to support application development or for customers to come and see and experience the equipment on their own. Traditional flow drill fasteners are the fastener designs that have been around for the last 20 to 30 years. These are the ones most commonly used in the automotive plants today. When using this type of fastener, not all joints and materials are suitable for joining. In order to use these traditional fasteners, we must fall within these guidelines. First, if we're going to join aluminum to aluminum, the flow drilled thickness should be less than 6 millimeters. The flow drilled thickness only counts the thickness of the materials that the tip of the screw has to penetrate through during the penetration or passage step. For steel joints, this thickness is going to be less. Typically, 2.5 to 3 millimeters is the maximum, and it will decrease as the strength of the steel increases, as you can see on the line graph. There are different types of fasteners that can be used to shift the curve to higher strength steels, but they do require special materials and heat treatments. Should we violate one of these stack-up guidelines, doesn't mean we cannot create the joint, but it may require a clearance hole. Clearance holes are often used when the layers are too thick, so greater than 6 millimeters, or if they are steels that are too strong and we cannot penetrate them. You can use multiple clearance holes, with each clearance hole and subsequent layers getting a little bit larger, and this helps to make sure the holes all line up during assembly in a manufacturing plant. We're not going to cover all the guidelines for flow drill fasteners in this video. If you have additional questions, please feel free to reach out to us through our website, www.semblex.com. Semblex is the largest manufacturer of flow drill fasteners in North America, and through our history of production, testing, and meeting with our customers and end users, we have identified quite a few limitations of this traditional technology. These limitations include the inability to flow drill safely through greater than 6 millimeters. You can certainly get a few screws to go through pieces thicker than that, but doing it reliably is quite difficult. We will get sheet gap formation if the top layer gets thicker than 2 millimeters without a clearance hole. If there are adhesives, this can break the adhesive bond line and weaken the joint. Some customers will have issues colliding with the edges of clearance holes, which can fault the installation process and requires rework. As the automotive industry moves towards electric vehicles, we are getting requests for leak-resistant flow drill fasteners with and without clearance holes. We are also being asked to speed up the installation process, which is currently at about 2 to 4 seconds. Customers want to go faster. Also, the EV market is pushing to get rid of debris generation. During that penetration step, when we flow drill the hole, you can get some slivers of material, especially if it's aluminum, or some of the plating can break away from the fastener. And then finally, as you saw in that line graph earlier, we cannot flow drill through steel stronger than about a 980 megapascal tensile strength. Semblex has spent the past few years working with our key customers and partners to create low-cost solutions to each of these problems. And today, we are proud to present our latest innovation, OptiFlow. OptiFlow is the next generation flow drill fastener. It features a catalog of modular proprietary design changes that are capable of surpassing the limitations that we just talked about. Certain modular changes will address different limitations, and they can be combined to create a fastener that works best in your application. You don't need every feature, you only need the ones that solve the problems you're facing. In the next videos in this series, we're going to look at each feature in the OptiFlow catalog. We're going to highlight which of the limitations it surpasses, how it can be used in a manufacturing environment, and what the implications on cost are. Our goal with OptiFlow was to minimize cost implications while improving flow drill fastenability. Hope you will join us for the next videos in this series.